Projections of solids, particularly the case solid axis inclined to VP and parallel to HP, that is axis inclined to one principal plane and parallel to another plane. So in the same category, in the previous classes we discussed about solid axis inclined to HP and parallel to VP, and today the next case. If you are provided with pen and notes, just write out the things what I am spelling now. A square prism, okay, a square prism of base side 35 mm, a square prism of base side 35 mm and axis height 65 mm is resting on HP by one of its side faces. The axis is inclined at 40 degree to VP. The axis is inclined at 40 degree to VP. Draw its projections. So a square prism is now given. Its dimensions are base side 35 mm, axis height 65 mm. It is resting on horizontal plane, okay, resting on HP, by which, whether by a base corner or base edge or side edge or side face, it is resting on HP by one of its side faces, okay, lateral faces. The object given is simply the square prism, okay, the square prism. You may just take it out from your solid model set, the square prism. So it is resting on the horizontal plane by one of its side faces. Totally how many side faces are in this square prism? Totally 4 numbers of side faces are there. So out of these 4 numbers of side faces, it is resting on the horizontal plane by one side face. The meantime, automatically the axis is now parallel to HP only. You can logically justifying this by your imagination. If the solid like square prism, all type of prisms, any prism, is simply lying on HP flat, obviously the axis now being parallel to HP only. But the axis need not to be parallel to VP. If the solid is standing in this way, consider it is your VP and this is your HP. If the solid is lying in this way, now the axis is parallel to both the horizontal plane and the vertical plane. But in this problem, the axis is inclined at 40 degree to the vertical plane. So slightly it is inclined with VP. So this is VP, that is HP. The solid is lying in this way, simply lying in this way. Axis is already parallel to HP and inclined at 40 degree to VP. This is what you needed to draw. So if you simply draw the 3D environment of this, so here you are having the solid square prism in this way. Okay, in this way. The axis is, for your reference purpose, I am highlighting the axis. The axis is parallel to HP and it is having inclination with VP, inclined to VP. So in this way, the solid is simply lying on the horizontal plane. Now you needed to draw the front and top views of the solid. Okay, like the previous cases also, here we needed to first draw the simple projection. A simple base view and a lateral view of the solid needed to be drawn first. By using the simple projections, we can go for implementing the axis inclination with VP in order to draw the final projections of the solid with respect to the given question. Okay, we can start from the scratch. So this is what the environment, just try to understand. In this way, the solid is simply lying on the horizontal plane. The axis is inclined to VP and parallel to HP. Now we are going to draw this. As usual, we can start with the XY line. Okay, and here, usually we are thinking that in order to see the base of the solid, we are having a regular practice. Whatever the inclination of the axis of solid with respect to HP or VP, first we need to make it perpendicular to that particular plane. In the previous cases, for example, if the solid is standing in this way, it is having inclination, axis inclination with the HP and parallel to VP. So what we did at first, we made the axis perpendicular to HP. We made the solid stand straight and the inclination to HP become perpendicular to HP. Then it is easy for us to see the base view in the top and the lateral view of the solid from the front. So in this way we solved the things in the previous case. Now also the solid is sitting in this way. So in the either in front view or in the top view, it is not possible to see the base of the solid. So what we needed to do is, here we needed to make the solid axis perpendicular to VP. Okay, because it is already inclined to VP. So what we needed to do is, we needed to make the solid axis perpendicular to VP. If you made the solid axis perpendicular to VP, then you can say in which view you can see the base of the solid. In the front view, you can see the base of the solid. In the top view, you can see the lateral view of the solid. Draw them. So this is nothing but here simple projection of the solid. Okay. So in front you can see, in the front view you can see the base of the solid. The solid here given is a square prism. A square prism. Its base side is 35 mm. It is lying on the horizontal plane in this way. So if you make the axis perpendicular to VP, you can see this square base in the front view, which need to be drawn in the XY line itself, because it is lying on HP. You need not to make any distance between the XY line and the base view. The base view need to be drawn on the XY line itself with the given dimensions of the square base. Yes, I just drawn the square base. Now I needed to give the names for that. It's a square prism, so it's having totally 8 numbers of corners, 4 base corners and 4 face corners. By our imagination, the corners which are all nearer to the VP are nothing but the base corners. In this way we are assuming regularly. So in this problem also the solid is going to stand like that. So this is nothing but the axis parallel to HP and inclined to VP. Here the corners nearer to VP are base corners. The corners nearer to far away from VP are face corners. This is face, this is base. So in this way if you consider, now give the names. Here I can give A dash, B dash, C dash, D dash, again 1 dash, 2 dash, 3 dash, 4 dash. All the base corners are stand behind the face corners. So I needed to give bracket for all the alphabets such as A, B, C, D. It's just all. And meanwhile, I think it is easy for you to mark the center point of this polygon. Simply by joining the diagonals, you can mark the center point of this square base. Mark it. Just after that, we have to project each and every corner towards the top view area. Just we completed the base view of the solid in the front view area. Just to project all the corners towards the top view area, which will facilitate you to draw the lateral view of the solid. Project it. Including the axis, because this will guide you how to draw the axis. And now here, you should not start the lateral view from the XY line itself. Maintain a small gap between the lateral view and the XY line in the top view area, because as per the problem statement, the solid is not touching the vertical plane. It is touching the horizontal plane only. That's why in front view, we made the base view to touch the XY line. But in the top view, you should not touch the XY line with the lateral view of the solid. If you made like that, automatically what your meaning is, the solid is touching VP, because anything you are doing with the XY in the front view is regards to HP. Anything you are doing with the XY in the top view is regards to VP. So here you should not make your lateral view of the solid to touch the XY line. Maintain a small gap. So I am starting from here. And the solid height given here is 65 mm. With that range, I am completing the lateral view of the solid. And this is axis. So use axis with the proper format. You should not use dashed line format for drawing the axis. You should follow dashed dotted line format to draw the axis of the solid. Okay, right. So just we completed the drawing of lateral view. Immediately you have to name the corners. So the corners nearer to XY are nothing but the base corners. B dash, A dash. So here A and B. There C, D. Here 1, 2. There 3, 4. Out of A, B, when you look from the top, B is visible to you. So A need to go inside the bracket. Here C is visible to you. D is invisible to you. The same way, out of 2 and 1, when you look from the top, 1 is falls behind the 2, and when you compare 3 and 4, 4 is falls behind 3. So in this way you can mark the names. Just we completed the simple projection of the solid, the simple front view, simple top view, namely basic base view and lateral view of the solid. Thereafter you have to implement the axis inclination given in the problem. In the problem itself, the axis inclination given is axis is inclined at 40 degree to VP. Okay, 40 degree to VP. Now we are maintaining the axis perpendicular to VP. So we need to make it inclined at 40 degree to VP. For that, what you need to do is the lateral view what you drawn need to be drawn in inclined way by maintaining 40 degree axis inclination with the VP. This is the thing what you already practiced in the previous case. In the previous case, you redrawn the lateral view of the solids by maintaining inclination with HP. The same way here, instead of maintaining inclination with HP, we are making a solid axis inclined to VP by drawing it in the top view area. Okay. So first you have to draw a pilot line with a 40 degree inclination in some meaningful distance. So this is nothing but 40 degree. Hope it is visible to you. Fine. And then this lateral view need to be drawn again in the inclined manner without changing the dimensions. That is very important, students. You should not change any dimension when you redraw this object to there. The name itself, you are going to redrawing it as per the dimensions. You should not change the dimensions. and I am continuously insisting you use your drafter for this task. If you didn't use your drafter, definitely the angularity relations between the side edges and the base edges will be violated. Obviously, we are a human being. We are not able to control the mistakes happened due to the normal scale usage. So use your drafter. So just to measure the things and redraw them. Here I am drawing the things approximately, okay? They are not same. But in your work, you can use the measuring tools in perfect way to draw the actual scale. The same way of naming here. C, D, this name here, that name here, A, B, and here 3, 4, and the 1, 2. Just after drawing this tilted lateral view in top view area, now you need to project each and every corner towards the front view area. Yes, projector. The same time you have to obtain the horizontal projectors from the previous front view. And the projector for 1A, D dash, 4 dash comes along with the XY line. You need not to draw it again. Okay. Now identify the points starting from A dash. Here, final A dash. Similarly, B dash. Here, B dash. C dash, C. Final C dash, D dash, D. Final D dash. And now face corners. 1 dash, 1. Here. 1 dash, 2 dash, 2. 2 dash, 3 dash, 3. 3 dash, 4 dash, 4. 4 dash. Okay, I identified the points. This after what I needed to do is I have to follow the 4-step procedure what I told to you in the class itself, in which manner you have to connect the dots in order to obtain the visible and invisible edges clearly. So the first rule is we have to join all the outermost corners as visible edges. Before that, it is better for us to have the list of the edges available in this solid. In this square prism, totally 12 numbers of edges are there. Base edges 4, face edges 4, side edges 4. So totally 12 numbers of edges are there. Just connect the outermost corners. Before that, we can have the list. The board is very small here. Let me to have the list. The base edges are AB, BC, CD and DA. The face edges are 1, 2, 2, 3, 3, 4 and 4, 1. And the side edges are A1, B2, C3 and D4. Totally 12 numbers of edges are there. First connect all the outermost corners as visible edges. Let me So I am joining. By using the HB pencil, okay? Yes. I just connected all the outermost points. Now, go to the list. Where I have connected AB, yes, I connected. BC, yes, connected. CD, no, not yet connected. DA, yes, connected. The same way for the face edges. 1, 2, no, not yet connected. 2, 3, yes, connected. 3, 4, yes, connected. 4, 1, yes, connected. And by considering the lateral edges, 1A, that is 1A, yes, connected. B2, yes, connected. C3, yes, connected. D4, yes, connected. So the solid is very simple. So with the first step itself, we can connect more than 80% of the edges. And only edges, few edges are not yet connected. They are CD and 1, 2. CD and 1, 2. So just go through the second step. The second step is connect the nearest face corners, remaining face corners as visible edges. So when you look the solid from this way, we are not going to look the solid from that way because that view is already drawn. Now we are working with the front view. So you need to see this lateral view from this way in order to obtain the front view of the solid. So if you look the solid in this way, just decide whether the edge CD is visible to you or not. Where is CD actually? Here the CD is there. The CD is there. You are looking the solid from this end. So automatically the edge CD is in the back side of the solid. When you are standing in the front side of the solid, the edge CD is in the back side of the solid. So it is not visible. So you can decide that it is invisible. And the same way, the 1, 2, it is here. So when you look the solid from the front, the 1, 2 is very nearer to you. It's directly in front of you. So it is visible. So you can connect like that. So now the 1, 2 and the CD are also connected based on their appearance. If it is visible, you can draw the narrow line. If it is invisible, you can draw the dashed line. So dashed line also need to be drawn with the HB pencil, don't forget. If it is invisible edge, we need not to darken it, we need not to use the HB pencil, we need to draw the invisible edge with 2H pencil, don't think like that. Even it is an invisible edge, you have to draw it with the HB pencil with the dashed line format. The format only need to change, you should not change the darkness. Okay. So this is nothing but the projection of the given solid. So first we drawn the simple front view and a simple top view of the solid. Thereafter the axis inclination, that is axis inclined at 40 degree to HP, is implemented by redrawing the top view of the solid. Thereafter, by projecting all the corners towards the front view area and by obtaining the horizontal projectors from the previous front view, we are drawing the final front view of the solid. Now the work is over. Okay. A hexagonal pyramid. A hexagonal pyramid of base side 30 mm. A hexagonal pyramid of base side 30 mm and axis height 75 mm, 70 mm, axis height 70 mm, base side 30 mm, axis height 70 mm is resting on HP, by one of its base corners, and the axis is inclined to VP and the axis is inclined to VP at 45 degree, inclined to VP at 45 degree, and two of its base edges being perpendicular to HP, that's enough, perpendicular to HP. So this is what the question here. And see the students, here I didn't mention that the axis is parallel to HP. Okay, axis is parallel to HP. If any data related to the axis is not given, you can by default take it as parallel to HP, because the inclination with the axis is given with respect to VP. So automatically you can imagine that the axis is inclined to VP and parallel to HP. Okay, the solid given is a hexagonal pyramid. Okay, a hexagonal pyramid. Yeah, here it is. Hexagonal pyramid. So it's a six-sided polygon. So in that totally 6 base edges and 6 side edges are there. 12 numbers of edges and totally 7 numbers of corners. 6 base corners, 1 face corner. Sorry, 1 apex point. So totally 7 corners are here. So this solid, as per the problem statement, it's going to rest on the horizontal plane by one of its base corners. Totally 6 base corners. Out of that, 1 base corner is going to rest on the horizontal plane. Okay, horizontal plane. And the meantime, consider it's your VP and my hand is HP. It is going to rest on the HP by one of its base corner. The same time, the axis is parallel to HP and inclined at 45 degree to VP. It is inclined. The axis is inclined at 45 degree to VP. And two of its base edges are perpendicular to HP. See, totally 6 base edges are there. Out of the all 6 base edges, 2 base edges, maybe you can consider this one and that one. These 2 base edges are perpendicular to HP. They are not inclined to HP. These 2 are perpendicular to HP and axis parallel to HP and inclined at 45 degree to VP. So in this way, the solid is simply standing on the horizontal plane. Now you need to draw the solid's front view and the top view. Okay, so just imagine in which way the solid is standing as per the problem statement. If you have the solid in model in your home, take it out by considering your nodes, one side as VP and another side as HP. Just try to stand the solid with the given conditions. Okay, one side, one corner need to rest on the horizontal plane and the solid axis need to be parallel to HP and inclined at 45 degree to VP, and the 2 base edges of the solid being perpendicular to HP. So in this way, the solid is standing on the horizontal plane. Now you need to draw it like the previous case. Here, our usual work. If the solid is standing like that, what we needed to do first? We needed to imagine the axis perpendicular to VP. So in the problem statement, the axis is having inclination to VP. Now we need to make it perpendicular to VP. If you made the axis perpendicular to VP, automatically you can see the base view of the solid in the front and the lateral view of the solid in the top, and draw the simple front view and a simple top view of the solid. Simply base view and lateral view of the solid. So I need to draw the base view. So the base view need to draw in the front view area. in which way we need to draw? As usual question, where should be, how should be the base and where should be the base? The base should be in the front view area. And how should be the base? The hexagonal base can be drawn in any way. In this way I can draw a hexagonal base, or in this way also I can draw the hexagonal base. In which way I need to draw? As per the problem statement, it is clearly mentioned that the solid is going to rest on the horizontal plane by one of its base corner. So, out of the first and second case, the second choice is satisfying our need. That is, one corner is resting on the horizontal plane. But you see the first choice, here one base edge is resting on the horizontal plane. Okay, but it is not in our scope. Our scope is we need to make one base corner resting on the horizontal plane. So the choice 2 is correct. In the same way, you have to draw the hexagonal base in the front view area. The two choices are there to draw the base view of the solid in the front view. The first choice is this one, the second choice is that one. So in the second choice, the corner, base corner is resting on the horizontal plane. In the first choice, one base edge is resting on the horizontal plane. The problem statement is we need to make the solids to stand on the horizontal plane by one of its base corner. So the second choice is more optimum for us. In the first choice, one base edge is resting on the horizontal plane. So it is not applicable for us. We need to go for the second choice. So in this way, you have to draw the base view of the solid in the front view area. Say hexagonal base and identify the midpoint. And it is actually a pyramid, so don't forget to mark the apex point and the slant edges. Okay, and the apex point can be named as usually O dash, and the base corners are A dash, B dash, C dash, D dash, E dash, and F dash. Okay. After that, just project all the corners. Project them. And now we need to draw the lateral view of the solid. In the lateral view, what we need to maintain is, as per the first simple front view, the axis needed to be perpendicular to the VP. And you have to start drawing the lateral view just with a small gap between the XY line. The reason I already told you in the previous problem. So maintain a small gap from the XY line in the top view area and then start to draw the lateral view of the solid. Actually the axis height given is 70 mm. So here you need to mark the point O, the apex point, and here it is A, B. So when you look it from the top, B is visible to you, A is invisible, and here C and F. When you look from the top, C is visible to you, F is invisible to you. So bracket for F, and here D and E. When you look from the top, D is visible to you, E is invisible to you. So bracket for E. Now connect all the base corners with the O to draw the slant edges. Yes. And here there is no place for drawing the axis line, because axis line is just inside the solid, and we need to draw the CO. So we need not to show the axis line. Okay. This is nothing but the lateral view of the solid. We just completed the simple front view and the simple top view of the solid. Thereafter, you have to implement the axis inclination of the solid. Here the axis inclination of the solid is given as 45 degree to VP. Okay, 45 degree to VP. Now the axis is perpendicular to VP. So first you have to draw a pilot line with a 45 degree inclination with VP, and by using that we can redraw this available lateral view in our required form. First draw a 45 degree inclined pilot line. So this is nothing but 45 degree. And thereafter this lateral view need to be redrawn here in inclined way without changing the dimension. For that I already instructed you, you can follow a box method. Just to put it inside a box, cover it, and then reproduce the box here, and then mark the corners of the solid. Measure them, measure it. I just redrawn this box here, and then I need to mark the corners. It is O, and here it is again A, B, and here C, F, and there D, E. Okay. Now the solid axis become 45 degree inclined to VP. See here, this is the pilot line which is drawn 45 degree inclined to VP, and now the axis is nothing like parallel to the pilot line. So if you maintain the pilot line 45 degree inclined to VP, obviously the axis which is parallel to the pilot line now attained 45 degree inclination with the VP. Okay. So now project all the corners. Including the apex point. Now obtain the horizontal projectors from the previous front view. Now mark the cut points. So starting from A dash and A, both will intersect here. I can mark the final A dash. Similarly, B, B dash here, final B dash, C dash, C, final C dash, D dash, D, final D dash, E dash, E, final E dash, F dash, F, final F dash, and again O dash, O, here O dash. Okay, and now by the first rule, we have to connect all the outermost corners as visible edges. Let me hide it. So totally the number of edges are, in base we have AB, BC, CD, DE, EF and FA, 6 base edges. And the side edges are OA, OB, OC, OD, OE and OF. Totally 6 side edges. So now I connected some edges by following the first rule. Just see through what are the edges already connected. Whether AB is connected, yes, connected. BC is connected, yes, connected. CD is connected, no, not yet connected. CD is not yet connected. DE is connected, no, DE is not yet connected. And EF is connected, no, EF is not yet connected. Whether FA is connected, yes, connected. Similarly, whether OA is connected, no. OB is connected, no. OC is connected, yes, it is connected. See, O dash C dash is connected. OD is connected, no. OE, no. OF, yes, it is connected. Right. Then, more number of edges are get connected with the first step itself. Let's bother about the remaining edges alone. These are the edges which are all not yet connected. Just follow the second rule. The second rule is connect all the nearest face corners, remaining face corners as visible edges. So if you are standing here and seeing the solid, the nearest face is here itself. But fortunately it is a pyramid, there is no face. So the point number 2 is not applicable for us. Go for the step number 3. In the step number 3, the step is join all the remaining another base corners as invisible edges. So here you are standing in this place. So the far away base is this one. Here some remaining unconnected corners are there. There you need to connect as invisible edges. Similarly, CD, DE, EF need to be connected as invisible edges. See, let me to connect C dash, D dash as invisible edge, D dash, E dash as invisible edge, and E dash, F dash also as invisible edge. I connected all of them by following the third rule. Right. And the fourth rule is lateral edges you need to decide by simply seeing the solid in the particular place. So I am seeing the solid from this place. Just imagine the edge OA is visible to you or not. OA is here. OA is here. You are standing there and seeing the solid. Whether the edge OA is visible to you? Yes, it is visible to you. So connect it as visible edge. OA duty is over. And OB, the same place, here BO, that is here it is OB. You are seeing it from this point. It is obviously visible to you. So connect OB as visible. And then you are standing here and seeing the solid. The edge OD, it is here, OD, just in the back side of the solid. But you are standing in the front side of the solid. Definitely the OD is invisible to you only. So connect OD as invisible edge. And the only one remaining edge is OE. Here it is, OE. You are standing in the front side of the solid, seeing the solid. The edge OA is in the back side of the solid. So definitely OE is invisible. So connect O dash E dash as invisible edge. Now the duty is over. All the edges of the solid circuit connected based on their visibility, whether they are visible or invisible. They just connected. Okay. So in this way we can complete this work. So this is nothing but the final answer for this question. What we did is first we drawn the base view and the lateral view of the solid. Thereafter we implemented the axis inclination of the solid with respect to VP, and here it is given as 45 degree to VP. So by drawing a pilot line and then redrawing the lateral view in the different alignment with respect to VP, we can draw the final top view. From that, by projecting the projectors from the current top view and the previous front view, you can draw the final front view of the solid.